Hello, hello. Hi, everyone. Am I audible? Just let me know. Just let me know, guys. Am I audible or not? Is there anyone there, or is it too late for everyone so everyone has gone to sleep? Hello. Hi, Shri. Late, late. Okay, am I audible or not? I was late because I was traveling and there was a miscommunication between some people. Uh, but sorry, I have gone home for Diwali. So, okay, audible. I was tester, yeah. This round was made by one of my friends at IITR. So, he asked me to test. Anyways, let us start then. Just a second. Yeah. So hi everyone. My name is Pradyumn and today we'll discuss the solutions to the first seven problems from today's Div 3, that is from A to G. And before we start, I will tell you about our courses at TLE Eliminators. So if you are someone who is stuck at just solving one or two problems per contest, our self-paced courses are everything that you need. We have structured the program into four levels so that you can start from wherever you are: beginner, intermediate, pre intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through recorded lectures by educators, followed by carefully curated practice problems, combined with guided hints and video solutions that help you understand the why and not just the how. We believe in helping you build real intuition. If you need more help, then you'll get instant doubt support from our high-rated mentors, which are like top 1% mentors, top 1% CPers in the entire India. So you are never left stuck. And beyond learning, you can enjoy leaderboards, progress tracking, internal contests, and PCDs to help you keep motivated and consistent. Pick the level that fits your goals and start learning today. If you are not sure that which level you should choose, then you can watch this video, which will guide you about the things in each level. And if you are still not sure, then you can watch the level specific video. That will explain you in detail what are the prerequisites, outcomes, and difficulty and topics in each level. So you can do that. All right. So let's start with the PCD now. Um, so this is the contest. Yeah. So the problem A was, you are given an array A of length n. Your task is to find the maximum possible average value of any subarray of the array A. Formally it doesn't matter really. Like, it's pretty simple. The statement is pretty straightforward. So what they're saying is that we have an array, right? We have an array, one, two, three, four, five. Let's say five length array, and we have to find out the maximum possible value of the average of any subarray. That means, let's say if we take this L2R, that is A2 to A5, and let's say we take its average, that is A2 plus A3 plus A4 plus A5 by 4. So this is the average, right? And so this is the average of this subarray. So over all the n into n plus 1 by 2 subarrays, like if an array is of length n, it has n into n plus 1 by 2 subarrays, right? So over all of these subarrays, we have to find the maximum possible average, right? So this is pretty straightforward. Like, first of all, they have told us in the problem itself that, like, in the output, we have to print an integer, the maximum average, and it can be shown that the answer is always integer. Like, they have just given us that the answer is always integer. So that is a big hint in itself, right? Like, average can be in decimal also, right? Average is a sum divided by the length, right? So here there is division. So there could have been floating point as well, the decimal answer as well. But they are telling us that for this problem, like, we can prove that the answer is always an integer. So that's a big hint. Like, why is the answer always integer? It must be pretty simple, right? It must be pretty simple. So actually, the solution is that what is the average? Like, just recall a property of the average. That is, let's say if you have an array a1, a2, a3 up to an, then like if you find out the average of this array, then definitely I can say that the average must lie between the minimum and the maximum. That is, this average of any array, like of any number of elements, it must lie between their minimum and its maximum. Because of course, average is the median, like average is kind of the central value, right? Um, like if you have only numbers 3, 4, and 5, then of course the average cannot be 2. Like there is no number to bring down that average less than 3, right? If you add more and more threes, then the average will go more and more towards 3, but it will never go less than 3, right? So therefore you can say this. Now what do we do with this? Like basically we understand that the average at maximum, it can be max value only. Like the average cannot be more than max, and we want to like find the maximum value, right? Maximum value of average. So if in the array there are numbers only till a certain limit, like if the numbers, let's say the maximum element is 5 only, like in our array, in our a1, a2 up to an, the maximum element is 5, right? Then if you consider any subarray, like any subarray if you consider, definitely it won't have any element more than 5, right? So definitely the average of every subarray, the average of any subarray is definitely less than equal to 5. We cannot get more than 5 if the maximum is 5, right? And can we get 5 then? If maximum is 5, then can we get 5 average? Like we prove that the average is less than equal to 5 always. It cannot be more than 5. So can we get 5? So yes, we can get 5. Like we can simply choose the subarray which has the maximum. Like let's say if you have this array 1, 2, 3, 5, 4. Okay, then you will just choose this subarray with a single element which is the maximum element, right? So that's how you can do this. Is it clear, guys? How we prove this? By the way, you can simply like take the brute force approach also. Like since n is up to 10, so you can simply iterate over all these subarrays, right? And then just take their average, and whatever is the maximum, just print that. That's also allowed in this problem. But in that case, you will have to play with floating point numbers and ensure that the output is an integer, right? You have to typecast it into an integer before printing it. So yeah, that's one thing. That's another way to solve it. Yes, it is just max element, and why it was blank element, I just proved it, right? Okay, let's show the code. Show code is pretty simple. Uh, int and cnn, take the input of the array and print the maximum element. So because I have this template, uh, the code is pretty simple because of that, right? So yeah, let's move on to the next problem. Beautiful string. You are given a binary string s of length n. Your task is to find any subsequence p of s such that the subsequence p is non-decreasing. That is, each character in p is not greater than the next one. Let x denote the string obtained by removing all characters of s of p from s. Let x denote the string obtained by removing all the characters of p from s while preserving the order of the remaining characters. Then x must be a palindrome. You need to only output any valid subsequence p that satisfies both conditions. If none exists, then output -1. Note that an empty string is both non-decreasing and a palindrome. Okay. So what they're saying is that we have something like we have a binary string, right? 0 1 0 1 1 0 1. Or let's take a sample, okay? Let's take this sample, the third one, or not third one. Let's take this sample, 1101, 1101, 0011, right? So the answer that they gave here is 3 4. That is basically what we have to print is that we have to choose a subsequence S, right? Such that it is non-decreasing. I mean, subsequence P. Like, we have to choose a subsequence of this string such that this P is non-decreasing. Here, so in this case, P is what? 0 1, right? And S must be, like here in this case, S is the remaining characters. So S, in this case, S is 110011, and this S must be a palindrome, right? P must be increasing or non-decreasing, and S must be a palindrome, right? So in this case, as you can see, like they have given this answer, which is 3 comma 4. So that satisfies both of these conditions, that P is non-decreasing and S is a palindrome. So for any given string, you have to print a subsequence which satisfies these conditions, or print that it is not possible, right? So there's just, like, some of you might be overthinking that, okay, if P is non-decreasing, then that means it must have some zeros first and then some ones first, right? And then maybe we can iterate on the number of zeros and the number of ones maybe, but I don't know how to proceed, right? And S is a palindrome. So S is the subsequent, like S is the remaining string. If we remove this numbers of P, then S is the remaining string, and it must be a palindrome. So maybe we can use two pointers, like one pointer at the start, one at the end. But you don't need to do all this. Like, I haven't thought about this method, but you don't need to do all this. You just have to just observe. Just observe that if you have all zeros, okay, this string, this string is non-decreasing and also a palindrome. Okay, like, if you can see this string having all zeros, it is non-decreasing and a palindrome both, right? And I can say the same for this string having only ones, right? So if my given binary string, like whatever is my given binary string, 0 0 1 0 1 1 0 1, if I just divide it into, like, if I just choose the string P as this thing, like it is named as P only, right? The first string, which is, yeah. If I just choose P as all zeros, like all of these zeros which are there, I just choose them in P, and the remaining are what? It is called X, right? Yeah. So the remaining are only ones. So in my string P, I'll have only zeros, and in my string X, I'll have only ones. So this definitely will be non-decreasing, right? And this definitely must be a palindrome, right? So this is the simplest way to solve this problem. Okay. Yes, this is the way to solve it. Okay. I hope you understood. Did you guys understand this? Okay. What is my Discord ping? What did? Please tell how to overthink. I am an expert in that, but not related to the problem solving things. Okay. How to stop overthinking? Just realize that it is div 3b, and it must be of like 800 rating. So the solution must be very simple, right? That you have that information that it is div 3 and it is the B problem. So it must be very simple, right? 220 pings. I don't open. uh, at the rate everyone messages. Anyways, yeah. So let us go ahead with C, or okay, the code for B, right? It's pretty useless to show, but okay. So we have to print the subsequence indices, right? Whatever indexes we are choosing in the first subsequence, we have to print that. So we have to, like, we'll print all zeros, right? So whatever number of zeros there are, that's the number of indices that we are printing. Like, just print the number of zeros, and then for all the indices, just print that index if it is a zero, right? Cool. Just iterate over the string, and if it is zero, then just print that index, and then we line. Okay. All right. So let's move on. We have C. Beautiful XOR. You are given two integers a and b. You are allowed to perform the following operation any number of times. Choose any integer x such that x is between 0 and a. Then set a is equal to a XOR x. After performing a sequence of at most 100 operations that transforms a into b. Okay, sorry. After performing a sequence of operations, you want the value of a to become exactly b. Find a sequence that find a sequence of at most 100 operations that transforms a into b, or report that it is impossible. Note that you are not required to find the minimum number of operations, but any sequence of 100, at most 100 operations. Okay, so basically the problem is saying that you have a number a, right, and you want to convert it into number b. And what you want is that what you can do in one operation is that choose a number x, right, such that it is between 0 to a number x which is between 0 to a, and set a to a XOR x, right? So the new value of a will be a XOR x, and you want to do the operations multiple times and in such a way that a reaches to b. Like, you have to make a to b, right, in at most 100 operations. Okay, so I have to print the operations whatever x you are choosing, and if it is not possible, then print -1, right? So for example, we have this test case 292 to 929, whose answer is -1. And for the rest of the cases, like, they have printed the solution, like they say 998 to 244. We can do, like, first XOR by 25, since 25 is less than 998, and then whatever the number is, it is, I think, greater than 779, so we can XOR by 779 and we'll get 244, right? So you have to find out the operations. So it is pretty simple. Like, if you just think about bitwise, okay, like, we have bitwise XOR operator right here. So of course you will think bitwise, right? There is no other option. Okay. So, all right. First of all, you have to realize a few facts. I mean, they are very obvious. Let's say A has 4 bits. I mean, not A. Let's say new variable. Let's say M. We have a number M which has 4 bits, and we have a number N which has 3 bits. Right? Then definitely we can say that N is less than M. Right? That's pretty obvious. Okay. That is pretty obvious. So, like, if we know that n has less number of bits than m, then definitely n is less than m, right? For example, if we have 1011 and something 111, like 0111, then also this is greater. Okay. Um, all right. So, like, why I'm telling you this is because, let's say we have a which starts with a 1, obviously. Like, if we just ignore the leading, there are no leading zeros. Okay. So a will start with the 1 in binary, and then there will be some numbers, right? If it is of x digits, then there will be a 1 and then x-1 numbers, right? So if this is a, then my point is that we can choose x to be anything having a 0 right here. Like, if x is a 0 right here, then we can choose anything for these digits. Like my point is that we can choose any digits for these if x is a 0 right here. Okay, do you guys get my point? That if x has a 0 right here, then we can, sorry, if a has a 1 and then some digits, then we can simply put the first bit to be 0, and then we are allowed to put any bits here, and that will still remain that x is less than a. So we can choose that x to take a XOR with it, right? So let's take an example to understand it better. Let's say we have 1011. A is equal to 1011 in binary, and let's say my b is equal to 1101. All right. So your a is this and b is this. Now what is the difference? So basically you want to flip these two bits, right? You want to flip these two bits. And of course, the property of XOR is that if you take a XOR with 1, the bit gets flipped. And if you take a XOR with 0, then the bit remains same, right? So if you want a to convert into b, so what you will do is, like, you will have a as this, and what will you take x? X you will take as 0, and then, like, okay, you can take 0 here, and then for these three bits you can take anything, right? So you want to flip this bit and this bit. So here you will place 1 1, and here you will place 0, right? So that's what you can take x, and if you take the XOR with this, then you will get b. So 1101, right? So this is how you can do it if both the numbers have same length, right? Like here, um, the leading thing was 1, right? In A, 1 was the starting thing, and at the same bit, B also had a 1, and like basically they were of the same length. That's why we were able to do this. That just keep a 0 right here on this bit, and whatever the remaining things are, just keep them, and it works, right? But what if a and b have different length? Okay, so like if length of a is equal to length of b, then it is solved. That is, basically we can just put a 1 on those bits where they are unequal, right? If length of a is equal to length of b, then x will have 1 at the bits where we want to flip, where we want to flip, right? And 0 elsewhere. So essentially what this means is that x should be equal to a XOR b, right? Because of course, if you want a XOR x to be equal to b, then this implies that x is equal to a XOR b, right? So if length of a and length of b is same, then we can simply put x as a XOR b. Okay. Then what if length of a, like the second case, length of a is less than length of b? Okay. So basically, let's say a has 4 bits, 1011, and b has 5 bits, 11001, like this. Okay. So what do we do now? What can we do now? So is it possible, guys? Like in this case, I claim it is not possible. Okay, guys. Like in the length of a is less, if length of a is less than length of b, then I claim that it is not possible to convert a into b using this operation that they have given. And why is that so? That is because if you see, like, you can never make this bit 1. Like this, consider this bit in a, it is 0, right? If you ever want to make this 1, like initially it is 0 1 0 1 1, right? This A is this. If you ever want to make this bit 1, then in X you would have to have a 1 here, right? On this position you have to have a 1 if you want to make it 1, right? But as soon as you put a 1 here, this X becomes greater than A, right? So that's why you can never increase the number of bits in A using this operation. Like if you want a 1 here, then you have to put 1 in X. But you cannot do that because that will make X greater than A. Whereas you are only allowed to do X less than equal to A, right? So that's why it is not possible. So if length of A is less than length of B, then it is not possible. If it is equal, then the answer is just A's or B. Okay. So do you guys get till here how it is A's or B? Just let me know why it is A's or B if you understand. Yes. Nope. So overfitters. Okay. Let me explain once more. That if your length of A is equal to length of B, okay, then what will happen is, like, what does this mean? It means that A is some number which is like starting with 1, of course, and then some dates are there, and B is also a 1, and some numbers are there, right? Because starting with 1, why? Because we are ignoring the leading zeros, like the leading zeros that are there, we are ignoring them, right? We can do that, of course. And also the length is same, so we can write it like this, that the number of bits are there, they are same. So if you want to convert this A into B, we can just choose X such that it has a 1 in those places where we want to flip. Like let's say we have 0 1 1 0 1 1 0 1 0 0. Let's say this is the value of A and B, so their length is same. And of course the first bit, so length is same means the first bit is same, right? So what will you choose? X. So of course in X the first bit will be 0, right? Then the second bit onwards, like basically this bit we want to flip 0 to 1. So we'll choose a 1 here, then 1 to 0 we'll choose a 1, then 1 1 we don't want to flip, so we'll keep a 0 in X. Then here we don't want to flip, so we'll keep a 0, and here we want to flip, so we'll keep a 1. So this is what we will keep X, so that if we perform A's or X, then basically wherever there are ones in X, it will flip the bit, and therefore A will become equal to B, right? And I claim that this X is definitely less than equal to A, because the first bit will definitely be 0, right? Because A and B both have 1 in this case, so X will have 0 in that. X will have 0, and since A has a 1, X has a 0, so definitely X will be less than A. So we can set A's or X equal to B, or that means X is equal to A's or B, right? That's what my point is. So do you get it now? That is the case for length of A equals to length of B. Okay. And if length of A is greater than length of B, I mean, if length of A is less than length of B, then it's not possible, because we cannot make this 0 bit to 1, right? Because whenever you try to take a XOR with 1, that will make X greater than A, and it is not allowed, right? And if length of A is greater than length of B, like for example, if we have um, 1 0 1 1 0 and 1 1 0 1, this is the case. Okay, then what you can do is, like in this case it is not possible to make it in one step. Okay, like let's say you just try to take X is equal to A or B, then it is not possible, because in this case let's say A is this and B is this. So what will you keep X? If you keep X as like you just put ones at all the places which are not equal, then you will get this, right? You'll get x value as this. But clearly you can see that x is greater than a in this case. So it is not allowed to keep x as this value, right? So what you can do is you can do it in two operations. Like first you can just flip all of the bits which are like not the last one. Like basically let's say we have this last bit, right? The last bit is 1 and we want to make it 0, right? And then there are the other bits. We have the last bit and we have the other bits. So first what we will do is we will flip the other bits. First we will flip the other bits, right? And while doing that, of course x will have a 0 right here, like because we don't want to flip this first bit right now, correct? So definitely x will have a 0 here, and that will ensure that x is less than a, right? So in the first step, we will take a XOR with x such that it flips the other bits. Like basically, this 1 to 0 we won't perform right now, but rather what we will do is we'll flip the other bits. So let's say here 0 to 1 means we have to flip it. So we will keep a 1 right here. 1 and 1 we don't have to flip. Then 1 to 0 we have to flip, and 0 to 1 we have to flip. So first we will take a XOR with this number. So it will flip the remaining bits, right? The other bits than the first one, right? So first we'll flip the remaining bits, and that will definitely have x less than a, right? And then what we'll do is flip the first bit, right? So let's say in this example, what we will do is a is 10110, right? And b is 01101. So first we will take the XOR of x with, like, first step we will first flip these 4 bits, right? So for that we will take a XOR with 01011, right? So after this step, what does a and b become? Like a will become 10110, sorry, 11101 if we take the XOR with this and this, and b of course remains the same, 01101. So what we did is we just made all of these bits same, and now just this first bit is different, right? This first bit is different, and so we can just take a XOR with 1 and 0 zeros. Like we can just take a XOR with this, right? And definitely this x will be less than equal to a, right? Because x is 10000, whereas a is 1 and then some digits. So of course this 1000 is the minimum, having a 1 at this position. Like if we have basically x we have 1000 and a we have 1 and something. So whatever is this something, it is definitely ensured that x is less than equal to a. Okay, so this is the entire logic. Like someone wrote in the chat that if the length of, yes, we'll discuss d. Yeah, someone said that if MSB is less than equal to MSB of a, then make x equals to a or b, and then output all set bits. Okay, so you will have to output it in some order, right? Like you cannot just print them all at once. But yeah, you can do this also. Just output all the set bits one by one. That will also ensure that x is less than equal to a, I think. Okay. So that's what my method is. That if length of a is equal to length of b, then just print x XOR a. So I mean a XOR b. If length of a is greater than length of b, I mean if it is less than length of v, it is not possible. And if it is greater than length of v, then just flip the other bits first and then the first one. Okay, so I'll just code this right now because the code that I have right now is like different. Okay, so I'll just code it very quickly. We have this function. So this CLZ just counts the number of leading zeros in a number. Okay, so length of A is equal to CLZ of 1 minus CLZ of A, right? Like if you have 0, 1, 1, 1 as A, then its length is 3. Or let's say the last bit. Okay, the bit position. Like in this case, the length of A, 0, 1, and 2. So second bit is the last bit, right? So this len A will contain a 2. Okay. Len B, CLZ of 1 minus CLZ of B. So if len A, if it is less than len B, so C out minus 1. Okay. If len A is equal to len B, then C out A is or B, and otherwise just print. Okay, I have to print 1 also, right? And otherwise just print 2 operations. Like first of all, just print A XOR B, XOR like basically A XOR B except the first bit. Like here you will print A XOR B, but you want the first bit to be 0. So you will take the XOR with a 1 right here also. So you will take XOR with 1 less than length of A. Like basically in the first step, your X would be the XOR of this part. So you don't want this digit to come. So you will take the XOR with 1000, right? So you will print this first, and then you will print 1000. Okay. So this should work. Let me just submit this. Actually, the reason why I did not have a code for this is because I realized the simpler method while explaining. Like the code that I had for this. Okay. The code that I had for this had a different logic, and it was a bit complicated than this one. Yeah. Okay. So let's move on to the problem D now. If you have any doubts, then you can DM me. Beautiful permutation. There's a permutation P of length n. Someone secretly chose two integers L and R and modified the permutation in the following way. For every index I such that I is between L and R, set Pi equals to Pi plus 1. Let A denote the resulting array obtained by modifying the permutation. You are given an integer n denoting the length of the permutation P. In one query, you are allowed to choose two integers and ask for the sum of this array either in the original permutation or in the modified array. The answer to the query will be the corresponding sum. Task is to, like your task is to find the pair L comma R that was chosen to obtain A in no more than 40 queries. Okay. So basically what they are saying is you have a permutation, right? What you have is a permutation that is a number from 1 to n, like an array which contains all the numbers from 1 to n exactly once in some order, right? So 1, 2, 4, 5, 3 maybe. So this is a permutation. right? Permutation P. And what someone did was someone chose a subarray, let's say this subarray, and he added 1 to every element. So this became 1, 3, 5, 6, 3, right? So what we can do is in one query, we can make a query of L to R. And what they will do is like either we can say 1 comma L, like either we can say give me the sum, give me the sum in the array P from L to R, or we can say that give me the sum in array A from L to R. That is, we can take any array and ask the sum of it between any two indices L and R. Like we can give him L and R, and he will give me the sum, right? And in 40 queries, we have to find out that which were the two indices where the increment happened. Like basically, in this subarray, all the numbers were added by 1, right? So we want to find out that which was the array to which the plus 1 was added, right? So that's the problem. So guys, just tell me one thing. Like I'll give you a simpler problem right now. Okay, I'll give a simpler problem to solve. All right. So the problem is that you have an array A. Okay, you have an array A, and there's a position I. Like there is a position I which is hidden. You don't know the value of I. What you can do is in one query, you can give subarray L to R. Like you can give any L comma R, and it will tell you that whether or not this I is there in L comma R. Like you can ask any L comma R, and it will tell you that is I in the range L to R or not. So if it is in the range L to R, then it will say yes. Otherwise, it will say no, right? And let's say this array length is n. Then you want to find out that what is the position of I. It is between 1 to n that is given to you, and you want to find out that what is the position of I. And you can ask that is it between L to R. You can give any L comma R. So what will you do? How will you solve this? Yeah, D was kind of cool. So any ideas, guys? That if you have an array and there's a single index which is special, I index, it has a special index, but you don't know that what is it. And in one query, you can only ask that is the ith index, like is the special number between L to R. And if it is, then the program will tell you yes. Otherwise, it will tell you no. So can you find like what is the minimum queries in which you can find out that what is this I? Start from L equals to 1, R equals to 1, and then move R. Yeah, like move R how? So how will you move R? Log n. Okay, so you are saying like doubling it every time or something, right? Like basically binary search. Like just keep L equals to 1 and do a binary search on R, right? So yeah, his idea is that what you can do is you can just fix L equals to 1, okay, and keep querying for 1 comma R. Okay, like let's say we have like this, and let's say this is the index. The index I is this one. So first you will query, let's in the normal way, first you will query for 1 comma n, or let's say this is 8, right? So you'll query for 1 comma 8, right? So of course you'll get a yes. Okay, then you will basically half the search space. So you will query for 1 comma 4, and then you will get a no. So you will know that the I exists in this range, right? So you will query some bigger one. So you will query like this 1 comma 6, right? And you will get a yes. So you will know that I is between in this range, and so you will query like this. So basically, you are just giving an active range for I. Like initially we knew that I could be anywhere from 1 to 8, right? And we won't make this query vessel. Like we no need to make the first query because it will always be yes. So initially you know that the answer is in this range, the value of I is in this range. Then you will query for 1 to 4, you will get a no, and then you will. So now you know that the value of I lies in this range. Then you will query for 1 comma 6. You will query 1 comma 6, and you will get a yes. So you will know that your I lies in this range now, right? And now you will query for 1 comma 5, and again you will get a yes, and you will update your range to this one. So you will know that I lies here. So it is a binary search kind of thing where your range is becoming half, right? So initially your range was this, the entire array. Then after that it became half and it became this, and then again it became half, it became this, and then again it became half, it became like this, right? So that's what you can do. You can just make queries of type 1 comma r and then be with your ways. But how does this idea help in our problem? So basically, in our problem, what we have is that um, we have an array P, which is some permutation, and an array A where a subarray is selected and the elements have added by 1, right? So let's say this subarray, the elements have been added by plus 1. Okay. So let's say if I give this, like what my idea is that I can find the left point. Like let's try to find the point L. Okay, let's just try to find the point L. Like this L comma R is there, right? This L comma R subarray in which the plus 1 has happened. We have to find L and R, right? So let's try to find the point L somehow. So what we can simply do is we can use binary search, okay, and try to query sum from 1 to mid, okay. Like just keep a value mid, right, and just query 1 comma mid, right? And in your query, what do you get? Basically, in your query, you get the sum of p, right? Like either you get sum of p, sum in p from 1 to mid, sum of p in this range 1 comma mid, or you can get sum of a in this range 1 comma mid, right? So what you can be sure, like what you can do now is that just do both of these queries. Like just do both of these queries, sum of p also and sum of a also, okay, and then just subtract that. Like let's say you got the answer, you got ans 2 from this and ans 1 from this. Like you queried first the sum of p in 1 comma mid, and you then queried sum of a in 1 comma mid, and you got ans 1 and ans 2 respectively. So if you do ans 2 minus ans 1, okay, like let's say you queried for index 5, like let's say in this p, you queried this 1 to 5, and in this a also you queried this 1 to 5. So basically these two indices have been increased, right? These two have been increased. So if you do sum of a minus sum of p, then you'll get 2, right? Because you will get one difference from this index, because plus 1 has happened here and 1 from here, and for the others you will get 0 difference. So you'll get 2 as the answer, right? So my point is that if the query that you do if the query that you do is after L, like let's say you queried like this, if you had queried only these three indexes, then the difference that you get, a minus p or ans 2 minus ans 1 would have been 0, right? Because you are not including the subarray which is having plus 1. And if you query like this, something which contains this array, that is something which has this left point. Like if you just query on this left point like this or beyond this left point, then definitely you will get ans 2 minus ans 1 not equal to 0, right? So you will know that if you query like 1 comma mid, okay, and you get a non-zero answer, okay, like if you query 1 comma mid and you get the difference is non-zero, that is greater than 0, then you will definitely know for sure that L is included in your range. Like your L is coming there in your range. That is, you are intersecting with the subarray which is increased, right? So you will know that L is less than equal to mid, right? And if diff is equal to 0, then you will know that L is equal to, L will be greater than mid. That is, you did not reach the left point like this. You did not reach the left point. Let's say you query like this. Then you did not reach the left point. The left point is right here, and it is outside your range, right? So you can just do this, and using this query of 1 comma mid, you can find out that what is the left point, right? So in this case, like if you do like this, then tell me guys, how many queries does it need? Like how many queries did we just use? Just let me know. Yeah, 2 login queries we used. This is probably of earlier. This is an earlier comment. So, but yeah, the answer is correct. I don't know why he wrote that, but it is 2 login. The number of queries that we did, the number of queries that we did was 2 login, and using 2 login queries, we were able to find the left value. Okay, but now we want to find the right value as well, right? So similarly, someone can think that we'll just find the right similarly, like just do queries like mid comma n, right? That will take 2 login more queries, and total it would be 4 login. But that is too much, okay, because we have only 40 queries, and n can go up to 2 into 10 to the power 4. So the log of 2 into 10 to the power 4, it is approximately, I think it should be around 17. Okay, 17 or 18, kind of 17 to 18. So if you do 4 login queries, then it will definitely be more than 40, right? You can do up to 2 login. 2 login is like up to 36 or something, but 4 login is too much. So what you would do for finding R? Like you have found an L, right? You have found the left index, but what about the right index? What will you do for that? Find the length of survey which is changed. Last element of P and A and difference gives number of increments. Yes, exactly. So what you can do is just query the entire sum for P and A. Like in P, just query the sum for 1 to n, and in A also just find sum from 1 to n. Okay, let's say this is sum 1 and this is sum 2, right? So if you do sum 2 minus sum 1, sum 2 minus sum 1, then of course you will get the number of indices that were increased. Okay, so that's what you will get. And actually sum 1 will be definitely n into n plus 1 by 2 only, right? Because this is a permutation. This P is given to be a permutation. So the sum one will always be n into n plus 1 by 2, because every element from 1 to n comes exactly once. And this sum 2 you can query. And if you do sum 2 minus sum 1, you will get the number of indexes. And therefore you will get the value of like r minus l plus 1. You get the value of this and you know the value of L. So you can find the value of R also, which would be the difference plus L minus 1, right? So this is the main idea here. Okay. Anyways, I hope you got it. Any doubts, anyone? If there's any doubts, just let me know. All right, Shrikant. Anyone else having a doubt or something? No. So your answer is no. Okay. I think you guys have no doubt. Let's just see the code. While we are seeing the code, just if anyone has a doubt, then they can type in the chat. So I have this function which queries, like I give it L and R, and it will query for me in both the arrays the sum, and it will just return the difference. Like I just give this function L and R, and it just returns me the difference between the two arrays. I have made this function to query, right? And in solve function, I have like what I'm doing is I'm just binary searching for the value of the start. Okay, like this start and end is the answer. Like start is the starting index and end is the ending index. So I'm just binary searching for value of start. So low equals to 0 and high equals to n minus 1. That is the start could be anywhere from 0 to n minus 1. So while low is less than high, mid equals to low plus high by 2. If the difference from the index is 0 to mid, like I just query the index is 0 to mid, and if the difference is positive, like it is non-zero, then my start is less than equal to mid. So high becomes equal to mid, and if it is 0, then I have to search higher. So low equals to mid plus 1, right? This is basic binary search. And finally, when low equal to high happens, then I'll set start equals to low, right? Now what I'll do is I'll just s- query for the sum of second array. So second array from 1 to n, and take the sum, like see input the sum, and your end would be equal to start plus temp minus sum 1, like temp minus sum 1 minus 1. So this is your thing, like L plus the length minus 1, right? And then just print the answer. Okay. All right. So we will move on to the next one. Beautiful palindromes. We call an array b1 to bm of length m palindromic if the following condition holds. So the palindrome condition, basically, if it reads the reverse, like if in reverse it is the same, then it is palindrome, right? You are given an array of an integers where ai is between 1 and n and an integer k. You are required to perform the following operation exactly k times. Choose an integer x such that x is between 1 to n and append x to the end of the array a. Your goal is to perform the key operations in such a way that the number of palindromic subarrays in the resulting array is minimized. Output the key integers you choose for each operation in the order that they are appended. Okay. So what they are saying is that we have an array. Okay. We have an array a1, a2, a3 up to an, and we have to append k integers. Like they have given this array and they have given an integer k, and we have to append Append means push back basically. Append k integers, uh, where they have to be between 1 to n, in 1 to n, such that in the new array B, that is, you will have a1, a2 up to an, and then you have k integers, right? Let's say b1, b2 up to bk. So this is the new array, right? Where first you have this already having already integers are there, a1 to an, and then you will have these k integers. So you want to make sure that the number of palindromic subarrays, palindromic subarrays is minimized. So I think you understood that what is the meaning of palindromic subarrays. Basically, the number of subarrays which are palindrome. Okay. So what is a subarray you know, and what is a palindrome you know, right? So the number of subarrays which are palindrome, you want to minimize that. Okay. So how do you actually solve this? Now let us get a few insights here. Okay. First of all, um, if you have an array, let's say 1, 2, 3, 2. So this is the input array, right? Let's say this is the input array, and you want to append four integers, or let's say three integers. Okay. So my point is that whatever you do, like the new array becomes B, right? So 1, 2, 3, 2, dash, 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 right? So you have to fill these dashes, right? So my point is that however you fill these dashes, the already sub arrays which are palindromic, like let's say this 2, 3, 2, this 2, 3, 2 was palindromic in the A itself, right? So definitely it will always be there in this B also, right? So like all the subarrays which are there already palindromic in this array A, they will definitely be there in B also. So this one is palindromic already, and also the length one subarrays, like all of these four, they are also palindromic, right? And they are also in this, right? Okay, and also the new elements that we add, the new elements that we added, all those single element arrays, like if we just consider this subarray or this subarray or this subarray, these are also palindromic, right? So whatever we do, we cannot avoid them to be a palindrome. So definitely the answer must be at least this, like um, definitely at least these many subarrays would be a palindrome in our final answer. Like what, which ones? All the originally existing subarrays, originally existing subarrays. So they, like whatever were there in A, they must be there in B also, and also the single element subarrays. The single element ones, they must also be in the, like they'll also be palindrome. So we cannot avoid them. Okay, but what we can avoid is subarrays like this. Like if you choose this subarray, you can definitely try to avoid this being a palindrome. Okay, so you have to try your best. Like while putting these numbers here, you need to try your best to make sure that this is not a palindrome. Okay, all right. So how do you actually solve this? There are many ways to solve this, but what I did, I'll tell you. Okay. So one thing that we notice is that what is a palindrome, first of all. So a palindrome is an array. It is an array which reads the same forwards and backwards, right? So like if I put it in a different way, like here I drew 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 numbers. So there's a center, right? There is this unique center. So for a palindrome, this center has to be there. I mean, if there's a unique center, then it is okay. It is there, and all the like pairs which are one left and one right, this has to be equal. Then if we go two steps left and two steps right, it also they have to be equal also. Then this also has to be equal, and this also has to be equal, right? Okay. So we have to like either this is the case, right? Either this is the case, or the case is that the length is even and the two center ones are equal, then these two are equal, then these two are equal, and these two are equal, right? So the point is that, okay, the point is that if an array like my point is that palindromic array if a palindromic array has an element which appears only once, having frequency 1. That is what I am saying. What I am saying is, if I have a palindromic array having an element with only frequency 1, that is that element appears only once, then definitely that element must be center. Like definitely the length of the array is odd, and the center element is that element. Like if we place that element anywhere else, like let's say if we place x here, then definitely x has to be here also, right? So my point is that if a subarray, like any array, if it has only a frequency 1 element, then definitely it has to be in the center. Okay, it has to be in the center, right? So of course that means that its adjacent elements must be equal, right? Like I must have something like this, that in between there is the element which is having frequency 1, and then its adjacent elements must be equal. So whatever there is written here, it must also be here. They have to be equal, right? So that is the one observation that I did, right? So in this question, like let's come back to the question now. In this question, we have to ensure, see, in my final array B, I have two parts, right? I have two parts. One part of the array is that already the elements that were given to me, A1, A2, A3, and A4. And the other part is the elements which were appended by me, like the elements which I appended. Let's say B1, B2, B3, B4. So all the subarrays which are only including this, like this subarray, this subarray, this subarray, this subarray, then this one, this one, this one, this one, this one, and this one. So all of these subarrays, if they are already palindromes, then we cannot do anything about it, right? We just have to ensure that all the subarrays which are of this type, like which overlap with this array B, like let's say this one, or this one, or this one, or this one, or this one. So all of these subarrays, and also maybe the ones which have only B in them, right? So we'll worry about them later. But my point is that all these subarrays which have this kind of overlap, like which are both in A and B. Okay. So first we'll take care of them, that they are not any palindrome, right? Like we want to make sure that all of these arrays that are being formed, they are not a palindrome. Okay. So what you can notice in all of these arrays, what you can actually notice in all of these subarrays, which appear in both A and B, you can simply notice that um, this B1 element is always there. Like of course, all of those subarrays which overlap with both A and B, of course this B1 is always there in them, right? So if we just try to put this B1 as a unique number, like if we just try to put this B1 as an element which is not there in any of these places, like from A1 to A4, whatever element is not there, like assume that for now there is no element which is, like assume that there is an element which is not present in these numbers. Okay, like I'll solve for this case first, that the given array the given array has at least one missing element. Okay, so what I'm saying is, if this b1 if this b1 I just put, let's say, x, and this x does not appear anywhere else, like from this a1 to a4 and this b2 to b4. So if this x element does not appear anywhere else in the array, then that means that in every subarray it will have frequency of 1 only, right? Like in every subarray which overlaps, like in every subarray which contains both a and b, it will have this b1, right? It will contain b1, and since this b1 is x and x is not occurring anywhere else in the array, therefore the frequency of x will definitely be equal to 1, right? And I proved that if it is equal to 1, if the frequency is equal to 1, then it has to be the center, right? It has to be the center. So what does that mean? That its adjacent elements also have to be equal. So this a4 and b2 must be equal for the array to be a palindrome, right? But what we will just ensure is that whatever we are keeping b2, we will not keep it equal to a4, right? Like we can simply keep this b2 not equal to a4. Okay, so that is simply what we can do. Like we can just keep a number which is not appearing anywhere here. Like we will just keep a number which is not appearing anywhere in this array as b1, so it is unique. And for b2 we will just keep a number which is not equal to a4, right? So that will make sure that any subarray this will make sure that any subarray overlapping with both a and b is not a palindrome, right? So we have made sure that any subarray which is overlapping with both a and b, like all of these subarrays, they will not be a palindrome. Like what we can just do is keep b1 equal to some unique number and b2 something other than a4, right? So we'll make sure that, like this will make sure that any subarray which overlaps with both a and b is not palindrome. Okay, so but we also have to ensure for these subarrays which are only there in b, like what is left, the subarrays the subarrays only there in b. Like basically we just made sure that any subarray overlapping with both a and b are not palindrome. But what about the ones which are there only in b, like these subarrays, this subarray, this subarray, this subarray, this subarray? So how do we make sure that they are not palindrome? So for that, what I just did is I ensured that all of the elements that I am adding, they are all unique. Whatever element that I'm adding, they should all be unique. Okay. So of course, if they are all unique, then it can't be a palindrome. Like a palindrome of length at least 3. Let's say we have a palindrome of length 3. Then of course these two numbers are same. These two are equal, right? So if a palindrome have and actually length 2 also. So if it is length 2, then these two are unique. I mean they're equal. Sorry. So my point is that any palindrome of length at least 2 cannot have all unique elements, right? So if I just fill this b1 to bk, to be all unique elements from 1 to n. Since this k is less than equal to n, right? It is given that this k is less than equal to n. So I can do that. Like I will ensure that all the elements that I add must be unique. Okay. So if I ensure that, then no subarray which is of length at least 2, no such subarray will be palindromic, right? So earlier I took care of these subarrays which spanned both A and B, like this, by just keeping B1 as the unique element. And I also took care that all the subarrays which are there only in B, they are also non-palindromic, by ensuring that all of them are unique. All the numbers B1 to BK, they are unique. Okay. So that's what the algorithm is. Like I'll just run it on a test case, 32523, let's say. So 32523, and the k is 3, right? So 32523, and here k is 3. So of course these, like this subarray is palindromic, this is palindromic, then this is palindromic, and like the single ones are also palindromic. So we cannot do anything about that because we can just add new elements. And now, like what we can do is we can add new elements. Like, so here what I will add. So I told you that here I will add a number which is not there in the array. So as you can see that 1 is not there in the array. So I'll add 1, right? And now here I can add any number which is not equal to this, right? I can add any number which is not equal to this. So let's say I just add 2. That is fine, right? And the third number, I have to ensure that I am not repeating anything. So I have added 1, I have added 2. Now to ensure that I am not, like I am not adding 1 or 2. So I'll just add 3 or something, right? That is fine. So that's what I can do. So as you can see that this is the B portion and this is A portion. So any subarray you take will not be a palindrome because of this one. Like this one is there, which is not there anywhere else. So this one will have a frequency of 1. So it has to be a center, but the adjacent two positions are not equal. So the subarray cannot be palindromic. And if you take a subarray which is there only in B, then obviously it can't be palindromic because all the numbers in B are unique. So you will never find repeating numbers, and therefore it is not palindromic, right? So we just solved for this case where A was not having all the numbers. Like here you can see that in this case, A did not have the 1 and a 4, right? So we could put 1 here. But what if A has all the numbers from 1 to n? Like the thing is that what if A is a permutation? Let's say 1, 4, 3, 2. So A has all the numbers from 1 to n. Then what do you do? Then actually we can simply print the permutation again. Like just print 1, 4, 3, 2 again. And you can easily see that there is no palindrome. Okay, like since the length of array is given to be greater than equal to 3, right? Length is greater than equal to 3. Therefore we can do this. That just print the permutation again. I mean, whatever, how many elements you want to take. Like let's say if k is equal to 2, then you can print this 2 elements again. Like the first 2 elements again. So as you can see, it will never cause a permutation. Like it will never cause a subarray to be created. All right. So that was the case. Like the first case was, if there's a missing element, then just put that missing element right here, and right here you can put any element which is not equal to this element, and then after that you can put any elements given that all of these are unique, right? And if you have permutation in the input, like all the numbers are present in the input, then just print the permutation again. Like whatever is the value of k, according to that you can just print the first k elements of this permutation. All right. So is it clear, or do you guys need more explanation to this? So a solution in which he used LRU cache to put the least frequently used element and maintain the order, and it gives accepted. least frequency, least recently used. I think that's what you mean, right, Vineet? Uh, yeah. So least recently used element. I think that should work. Why that works? Let me think about that. Meanwhile, you guys can ask other doubts if you have. Meanwhile, I'm thinking about that. So yeah, I think like it should work intuitively. Like my intuition says that it should work, but I'm just looking for a proof of it. Uh, just a second. So right now I'm on E. Like I just finished E. Thank you, PVP Geek. Vineet, just DM me on Code Forces. Like, okay, I'll just think about this and I'll do a comment on the YouTube live stream if I get a proof of why it works. Okay. All right. So let's see the code now. So first of all, we have the input L int nk c nk. Take the input of array. So first I'll find out that what is the number which is not there. Like I will try to find out a number which is not present in the input array. So in a set, I just insert all the numbers from 1 to n, and I remove the ones which are like in the array A. So for all the elements in array A, I just remove AI, right? So s dot erase will erase the element if it is not there. I mean, if it is there, right? Then if s dot empty, that is all the elements from 1 to n occurred in the array A. That means that A is a permutation, and we can print the first k elements of A, right? So print AI and print M line, right? And okay, then what we can do is um, like okay, in this case it is if s dot empty, that is if array has all the elements. Like this is the case where A is a permutation, and so here if we reach, that means A is not a permutation, right? So I'll just store this in O, s dot begin. So s dot begin is any a number which is not there in A. So O is a number not in A, right? And then I will just like print O as the first number, right? And yeah, what I will do is I'll reuse the same set, like this set that I made right here. I'll reuse it to ensure that I do not have any duplicates in my array. Okay, like whatever numbers I'm printing, I don't have duplicates. So I will use that same array S. I mean the same set S, and I will insert the numbers one to n in this, and then I will erase O. Erase O because I have printed O right here. And also I erase n a of n minus 1, that is the last element, because I don't want to print it just yet, right? Like if needed, I'll print it at the end. So right now I just erased it from the set, right? So I just erased O because I printed that, and I erased a of n minus 1 because I don't want the next element to be a of n minus 1, right? So I'll just do this k times, k minus 1 times, because I have printed O. So for the rest k minus 1 digits, I have to, like, I'll just print as not begin, and then I'll erase that element. Okay. And if s becomes empty, that means I have only left with a of n minus 1. So I'll just print a of n minus 1, right? So this will happen when I have k equals to n, right? Like this will only happen when I have k equals to n. Like I'll show you guys. Let's say 1, 2, mm, 2, 3, 4, 2. Okay, something like this. And k is equal to 4. So what will happen is I'll place a 1 right here. And in my set, I had initially 1, 2, 3, and 4. But I will delete this 1 because I placed it here. And I'll delete this 2 also because it is the last element. But then I'll place 3 here, 4 here. But uh, now I need one more element, right? So I'll have to place 2 here. So this will only happen when I have k equals to n. Like I have to print n elements, then it will happen. So yeah, I just asserted k equals to n, and I is equal to the last one, k minus 2. I mean, this is just to debug my code. Like in case some runtime error happens, so I will know that uh, my code is wrong. Like basically, this assert statement, what does it do? Assert basically, it will give a runtime error if this condition is false. Whatever you write in here, if it is false, then it will throw a runtime error. So if you submit the code and you get runtime error on test or something, then you will understand that it is this statement which is not true. It has to be true, but it is not true. So you will know. So it is easier for you to debug, right? So in contest, I wrote this. Anyways, so this is solution. So any doubts, anyone? You solved G in contest? Like I solved it after, I think, around 5 minutes after the contest ended. Like till F, I solved very quickly, but the G problem I solved after the contest ended, 5 minutes after the contest. Actually, I tested the contest. I did not give it officially. So in the virtual that I gave, I solved it after the contest, 5 minutes later. But anyways, so let's solve F now. Beautiful intervals. You are given an integer n and m. Okay, you are given an integer n and m intervals. Each interval is of the form li comma ri and satisfies 1 less than equal to li less than equal to ri less than equal to n. Note that there can be duplicate intervals. Let P be a permutation of length n containing all the integers 0 to n minus 1 exactly once. There is a multiset M which is initially empty. For each interval li comma ri, consider subarray P of li comma ri. Compute the max of this subarray and insert vi into n. So like for all the intervals that they gave us, li to ri, we have to first compute, um, consider this subarray, compute its max, and insert it into the set M or the multiset M, right? And after doing all the intervals, M would be equal to V1, V2 up to Vm, right? Because there are small m intervals, so there would be small m elements in this multiset. And finally, we have to construct a permutation. Like we have to, the cost of this max, like the cost of this M is defined as the max of, sorry, the cost of this M is defined as the max of this multiset. Okay. So to minimize the cost, we have to construct a permutation P such that this cost is minimized. Okay. And I have to print the permutation P. Right? So this is the problem. Like what we have is we have been given an integer n. That is, the length of permutation must be n. Okay. And I have been given some intervals. 1 interval, 2 interval, 3 interval, let's say 4th interval. And we have to, what we do is, for each interval, we consider that subarray. Like consider this subarray find its max, right? And then insert it into the multiset M. So for all these subarrays, find their max and insert it into M, right? And then find the max of M, right? And that is the cost. So we have to print a permutation to minimize the cost. Okay, that is what we want to do. All right. So how do we actually solve this? So look at the bigger picture. Like first of all, just start by looking at the bigger picture. What is the bigger picture? It is that what is the cost? Cost is max of something, right? The cost is max of something, and you want to minimize this, right? So what can be the minimum? If the cost is the max of something, some multiset, and we want to minimize this. So what can be the minimum value of the max? It can be zero, right? Like possibly it can be zero. So we want that the max of this multiset M should be equal to zero. So we will see that is it possible or not. Like can we make this max equal to zero or not? Let's see that. So if max is equal to zero, max of M, max of this set M equal to zero, that means that all elements in M, all the Mi which belong to this M, they have to be greater than zero. Mi has to be greater than zero, right? That is the max of, like, what is Mi? Mi is the max of ith interval, right? Mi is the max of Li comma Ri, right? So this has to be greater than zero for all I. If we want max of M to be zero, that means there has to be no zero in M. Therefore, all of the elements that are in M have to be greater than zero. So that means that max of all the subarrays that have been given, like all of the intervals that are given the problem, they have to be greater than zero. Okay, do you guys get till here? Like for example, if we have in this case, um, like we have 1 3 and 2 4. Like let's say our permutation is 3102. Like this is the answer that we have to find. And the intervals are what? The intervals are 1 3 and 2 4. So as you can see that the max of this 1 comma 3 it is 2, and max of this 2 comma 4 it is 3. So as you can see that the max of all the intervals they are greater than 0. Like we don't have a 0 in here. So therefore if we take the max of this, like this is the multiset M, right? Our M is 2 comma 3. So if we take the max of this, it will be 0. So basically, if we want max to be 0, then all the numbers that are there in the set should be greater than 0. Therefore, the max of all the intervals must be greater than 0. Therefore, what does it mean? 0 must be there in Li comma Ri. Right? That is in the array A, like in whatever array we construct. For each interval Li comma Ri, 0 has to be there in each interval. Okay. And only then we can have the max equal to 0. Right? So guys, when can we make an array like that? Like when can we make a permutation like that? So in such a way that 0 should be there in all the intervals. And also the array has to be permutation, right? The array that we print must be a permutation. That is all the numbers from 0 to n minus 1 must occur exactly once. They cannot repeat any zeros. So guys, what is the condition? Like when is it possible? When is it possible that 0 is there in all Li comma Ri? Just tell me guys. overlapping intervals. Yeah, like if all the intervals are overlapping, that is, they have at least one element in common. Like basically, wherever we put zero, like this is the permutation, right? We can put zero at any one place. So if I put zeros at some place, then all the intervals must pass through that place, right? So that means all the intervals must have, sorry, all the intervals must have a common intersection, right? And there we can place a zero. So we will get the max of all the intervals as greater than zero, and therefore the max of all those maxes will be zero, right? So the first case is that if all intervals are overlapping, then just put zero there. Okay, that is fine. So then you will get the answer equals to zero. Okay. Then second case, um, if it is not zero, like basically if not able to make zero, try for one. Try max equals to one, or max of m is equal to one. That is, of course, if we are not able to make zero and we want to minimize it, then the next thing we'll try is max of m equals to one, right? So what does that mean? That means that we should not have like max of a of li to ri. This should not be equal to one. Like my point is that for all the intervals, if I compute the max, if I compute the max of that, it should not be equal to one, right? Because I know that at least one interval will have max equal to zero. Like because the first condition is false. Like there is no intersection. Like there are two intervals which are having no intersection, right? Or I mean, not all are overlapping. So therefore, I know that whatever I do, I cannot have max zero. That means I'll have at least one zero in my set, right? So um, I'll definitely have max equal to zero at some point. Like in my multiset M, I will definitely have a zero, right? At this point, if I'm reaching, I'll definitely have a zero. So if I want that max of M should be one, then of course I cannot have a one as the max of any of my subarrays, right? Because if I have one also in my max, I mean, in my multiset M, if I have one also, then its max will not be one. It would be two or more, right? So I cannot have a one in here. That is for every subarray, I cannot have a one as its max. Like I can have zero as the max, or I can have more than two. Okay, like for every li comma ri, for every li comma ri, the max of that interval should not be equal to 1. That means either it is 0, first case either, sorry, spelling is either it should be equal to 0, or second case it should be greater than equal to 2, right? So what does that mean? So equal to 0 means what? Equal to 0 means it doesn't have a 0. Like the max of li comma ri is equal to 0, like in the array, in our permutation from the indexes li comma ri. If the max is equal to 0, then that means that this subarray does not contain 0, right? It does not contain 0. So either my subarray should not contain 0, or the max should be greater than or equal to 2. That means it should contain both 0 and 1. Contains both 0 and 1. Okay. So my point is that for every subarray that I have, like every subarray either should not contain 0 or it should contain both 0 and 1. That means every subarray, if it contains a 0, then it has to contain a 1 also. Okay. Right, guys? Do you get till here? Let me know, everyone, that if I want my max of capital M to be equal to 1, if I want this, then that means that for every interval, the interval's max should not be equal to 1. Because if I have an interval whose max is 1, then my multiset will contain both 0 and 1. And therefore, my cost would be more than equal to 2. So I should not have a max which is like equal to 1, right? So if I cannot have a max which is equal to 1 for every interval, then that means that every interval should either not have a 0, then its max would be equal to 0, or if that interval has a 0, then it has to be 1 also, right? There has to be 1 also in that interval, because otherwise the max would be equal to 1, and that we don't want that. So either each interval should have a 0, I mean for each interval either it should have a 0, I mean either it should not have a 0, or if it has a 0, then it should have a 1 also. Okay, that is the condition. So did it get till here? Shreyansh says yes. Okay. So now what you can see, you can simply say that um, like you want to just put a 0 and 1, right? Like you want to make an array, you have been given some intervals, and you want to make a permutation. Let's say I've been given these intervals. Okay. And you want to just put some numbers, like you want to put 0 and 1 in such a way that every subarray which has a 0 must also have a 1, right? So let's say if I put the 0 in here. Okay, if I put a 0 in here, then where do I put the 1? Where should I put the 1? So the thing is that I cannot put the 1 anywhere, because let's say if I put a 1 here, then for this subarray it is messed up. Like for this subarray has a 0 but doesn't have a 1, right? And if I put a 1 in here, if I put a 1 here, then this subarray will get messed up, because it has a 0 but not a 1, right? So I cannot put a 0 here. So basically the problem is what? The problem is that I can neither put a 0 on its left side, I cannot put the 1 on its left side, because this point is a starting point for this interval. Like the problem with this point is it is a starting point for this interval. Therefore I cannot put 1 here, and also it is an ending point. It is an ending point for this interval, so I cannot put a 1 here, right? So since this point is both a starting point for an interval and an ending point for an interval, I cannot put 0 here. But what I can do is, like, I can simply put 0 as a point, like as a at a position which is not both starting and ending point, right? Like either it is starting or it is ending, or it is neither of them. That is fine. So if it is a starting point, like let's say if it is an ending point, then we can put a 1 here, because it is not a starting point, right? And if it is a starting point, let's say we put it here, not here because it is an ending point for this one. Let's say if we put it here, so we can put 1 to its right. So that's how we can put it, right? Like we have to put a 0, we have to put 0 at a point which is not both which is not both a starting and an ending point. Okay, so that's what we have to do, and then we can put 1 accordingly, so that each interval doesn't have both 0 and 1. I mean, sorry, each interval which has a 0 must have a 1 also. So that's how we can make max equals to 1, right? But what if, okay, till here, do you guys get it? Yeah, I have noticed this also. Like Div 3 problems have somewhat higher rating. Like they are overrated actually. Okay, Shreyansh. So yeah, if we want max equals to 1, like just let me just revise it. If we want max of m equals to 1, that means that the max of no interval should be equal to 1. So that means that every interval should either have, like it should either not equal to 0. Like for every interval, its max should be either equal to 0. That means it does not contain a 0, or its max should be greater than or equal to 2. That means it contains both 0 and 1, right? So for every interval, if it contains a 0, we want it to contain a 1 also, right? So we'll place it in such a way that every interval either has both 0 and 1, or it doesn't have a 0. Okay. So we'll place a 0 at a point which is not both the starting and ending point, right? So let's say if we put it as starting point and it is not an ending point for some interval, then we'll place a 1 to the right of it. So every interval which contains a 0 also has a 1, right? Um, and yeah, so if we can find a point which is not both a starting and an ending point, then we can make max equals to 1. But now, what if there is no such point? What if there is no such point which has, like, which is not both a starting and ending point? Like, what if all points are both starting and ending points? Then your best bet is max equals to 2. Like, max of that multiset equals to 2. Okay. So, how do you make that? Like, can you actually make that? So, essentially, what it means is that every subarray, like, basically, max equals to 2 means what? That every mi should not be equal to 2. Okay. So that means that um, the max of all intervals should be equal to 2. Like what I mean to say is, if you want to make max of m equals to 2, that means your m must not have a 2, right? So that means none of the max values of all the intervals should be equal to 2. Like you cannot have the max of an interval as 2, right? So that means that if you have a 0 and a 1, if you have both 0 and 1 in your array, in your interval, if you have both 0 and 1, then you must have 2 also. Must have 2 also. Okay. So how do you ensure that? Like, can you always ensure that? That all the intervals which have 0 and 1 must have a 2 also. So yes, actually we can ensure that. It is quite easy. Like what we can simply do is, we can simply put 0, 2 and 1. Like if we have an array, let's say we have an array and we want to fill it with 0 to minus 1, like we want to make a permutation, then just ensure that 0, 2 and 1 appear in this order. Okay, like first 0 should come, then 2 should come, then 1 should come, right? So that means that whenever there is both 0 and 1, like let's say this subarray or this subarray, or maybe if you have more elements, then this subarray or maybe this subarray. So every subarray which contains both 0 and 1 will contain a 2 also. Okay. So therefore you will never have max equals to 2 in your set M. Like in your set M, it will not contain 2. Okay. It will not contain 2. So if you just ensure that there is 0, 2 and 1 in this order in your array, then your max will not contain 2. And then you can easily, like basically you can print any permutation which has this relative order of 0, 2, 1. 0, 2 and 1. Okay. So yeah, and it will ensure that your max equals to 2. What do you mean, Shreyansh? In case of case 2, what is case 2? In case 2, we want 0, 1 together, and in it we are separating them. We are separating them. Why do you say we're separating them? Okay, in case 2. So you mean in this case where we want max equal to 2. So what actually, no, that is not true. Like what I am saying is that okay, we checked for 0 and 1, right? Like we checked that can we make max equal to 0, and the answer was no. Then we checked that can we make max equals to 1, and the answer was no. So now we are trying desperately for max equal to 2. Like we just want to make the max of M equal to 2. Okay, that means we want that in multiset M we should not have a 2. Okay, in M we should not have 2 because we know that we definitely will have 0 and 1. Like whatever we do, we will definitely have 0 and 1, but we should not have 2 in our like in our max. Okay, so we are just trying to do that. Like we don't care about ones anymore. Like only in this case we cared that we should not have a 1, right? But since we observed that all the points are both starting and ending points of the interval, so we concluded that we definitely will have a 1. So we don't care about that anymore. Like because we know that we will always have a 1 and a 0 in our set. So now we are just trying that 2 does not come in our set. So we will just ensure that wherever there is 0 and 1, wherever there is 0 and 1, we have a 2 also, right? Like because we have just checked that 1 will always come. Like if it was possible that 1 doesn't come, then we would have just printed that only. Like we would have printed a permutation in which 1 doesn't come. But since we have reached this point, that means that 1 is bound to come. So we don't care about that anymore. We just care that 2 should not come. And to ensure that, we will just put 2 in between 0 and 1. Okay. Okay, Shreyash. Okay, your name is Shreyash. I was calling it Shreyansh. My bad. Okay. So yeah, that is the entire logic, and we'll code it now. Like I have the code for it, but it was wrong because I forgot about one thing. So I'll just fix it. Yeah. or pos is equal to 1. Okay, this should work. Let me just try to submit this. Then if it is accepted, I'll explain this. Yeah, it worked. So yeah, what I did in the code was that, okay, I just took the input int nm, c in nm, and so first realize that we want to do, like, what we want to check is the intersection. Like, the first step was, can we make max equal to 0? Can we make max equal to 0? So for that, we just have to find out the intersection of li ri. Like, if we want max equal to 0, then we just want to find out that, do all the intersection intervals have an intersection, right? So I just computed this intersection in L comma R. Like, initially I'll have L equals to 1, R equals to N, and as I'm taking the input, I will set L, like, let's say A comma B is there in the interval. So I'll set L equals to max of L comma A, R equals to min of R comma B. So I'll just take the intersection between L comma R and A comma B, right? And also I have this vector of booleans, start and end. That is, start of I is true if I is the starting point of some interval. Okay, otherwise it is false. So initially they're all false. And as I'm taking the input A comma B, start of A becomes true. That is, A is the start of some interval and B is the end of some interval. So end of B is true. Now first case, if L is less than equal to R, that means if your if your intervals have some intersection, then you will just print 0 at that position. Like, if I equals to L, then print 0. Otherwise print count plus plus. Like, I have a counter starting from 1, so it will just print 1 2 3 4 up to n minus 1, and in between, like at I equals to L, it will print 0. All right. So basically just print 0 at that index where it is intersecting, and all the other indexes just print randomly. Okay. Then if we reach here, then that means you have, like now you have to try for max equals to 1. Try for max equals to 1. Okay. So, like, I will find a position which is not the start and the end. Like, find a position which is either not start or not end of some interval. So for I equals to 1 to n, if not start not start of I or not end of I, then I'll set flag to true, and the pos variable equals to I, and I'll break, right? So if flag is true, that means max equals to 1, and we have to just put 0 at pos. So ans of pos equals to 0, right? And if this pos is the starting point of some interval, or if pos is equal to 1, like if pos is starting point, then of course we'll put at pos plus 1. Like, we'll just put 1 to the right of this 0, and if pos is the starting point also, then also we'll put 1 to the right of this 0. Otherwise we'll just put 1 to the left of this pos, right? And then we will just fill the remaining indexes with random numbers. So from 0 to n minus 1, we'll just put them. So count equals to 2. They will start from count equals to 2, and we'll just do answer 5 equals to count plus plus. If this answer 5 is minus 1, that is, it is not filled with 0 or 1 by now. Okay. And then we'll just print the ans vector. And otherwise, like, we basically did not find any index for which start I and end I are both, like, either one of them is false. So that means max equals to 2. So to make max equal to 2, we can just print 0 to 1 as the first three numbers, and then we'll just print 3 to n minus 1. Right? So this works. So I think it should be fine. Okay. Let's move on to the next one now. The last one for today, which is G. This PCD is already too long now, so I'll make it quick. So the problem G was pretty simple. Like, the statement was pretty simple. Okay, 2150. Actually, it's inflated only. Like this problem is not 2100. Like if you see a div2 and it is 2100, then it is definitely much harder than this problem. Div3 2100 is much easier than div2 2100, but okay, it was tough, but not this tough. All right. But anyways, I mean, I would rather call it 18 or 1900 only. All right. So, anyways, we have G. A tree is called beautiful if the sum of the products of the vertex labels for all its edges is a perfect square. More formally, let E be the edges in the tree. It is called beautiful if the value U into V, ka sum, is a perfect square. There is S is equal to x square for some x. You are given an integer n. Your task is to construct a beautiful tree having n vertices, or report that it is not possible. Okay, so it is purely constructive algorithm. Arman, I think it has uh, answered. Someone has answered, right? Like I think it should be accurate if it is by C list. Yeah. So the problem is pretty simple. It just says that we have to basically. First of all, let me just clear this out. And first of all, let me empty the recycle bin. For some reason, it is okay. Yeah. Anyways, so what we have is we have been given a number n, right? And you have to make a tree such that just a minute, guys. Yeah, hi. So what I was saying is we have to make a tree. Like what we are given is we have been given a number n, and we have to make a tree with n vertices numbered from 1 to n. 1, 2, 3, up to n, and it should be a tree. And it would make such that the sum of all the edges, like sum of the product of numbers over all the edges, is a perfect square. For example, they have given a sample, like for n equals to 4. For n equal to 4, they have made this tree. This 4, 1, 2, and 3. Right? So if you just find out the sum of all the edges, like here it is 4 into 1, 4, then it is 1 into 2, which is 2, and 1 into 3, which is 3. So if you add it, 2 plus 3 plus 4, which is equal to 9. Right? So that's how they have gotten that. Like they have gotten this 9. So 9 is a perfect square. So this is the tree, which is fine. Like if you have n equals to 4, then you can print this tree and it is fine. Okay. And for n equals to 2, it is not possible. Right? If n equals to 2, then the answer is -1, because for 2 you have only one tree, right? If you have a 2, then you have only one tree, and for this the value is 2, right? And which is not a perfect square. So for n equals to 2, the answer is -1. So I have to just construct a tree such that it is a perfect square. Now this is the kind of problem that I hate, right? Like you have to just come up with something. I'm not creative. Like the thing is that I'm not creative, and therefore I don't really know how to solve this. So usually what I do is I just run a brute force. Like in these problems, what I do is I just run a brute force solution, and then I just try to guess a pattern. Okay. So here also in the contest, I tried to write a brute force solution. That is, you can see here, I just wrote this. Like here I have a function which takes in the number of vertices n, and it will print a tree. Like it will print the answer, but it will like basically iterate over all subsets of edges. Like see, what is a tree? What is a tree? Like if I have n vertices, 1 to n, 1, 2, 3, 4. I mean, sorry. I have n, let's say I have 4 vertices, 1, 2, 3, 4. Right? So basically, I have 6 edges, right? I have 6 possible edges, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. So these are the 6 possible edges which are possible if you have a tree, right? Of course, only 3 of them will be there at a time. Like you will choose any 3 of them and it should form a tree. That's what a tree is, right? A tree is basically tree is a subset of edges. Subset of edges of size n minus 1, and also such that there are no cycles. Like basically, you have 6 possible edges right here, and you want to choose 3 of them, right? But you cannot choose these 3, right? 1, 2, 1, 3, and 2, 3, because that will form a cycle. So you want to choose n minus 1 edges, and also they have to connect it also. Like yeah, that's one more condition, that you have to choose n minus 1 edges such that there are no cycles and they are connected. All right. So what I just did was I just listed out all the possible edges. Like for n vertices, there are basically nc2 possible edges, right? So I just listed them out, and I just iterated over all the n minus 1 length subsets. Like I just iterated over all the subsets which are of length n minus 1. So how many would be there? There would be nc2 choose n minus 1 subset are there, and I just iterated over all of them and just checked if they form a tree. And if they formed a tree, then I just checked that um, is there some a perfect square or not. So a pretty brute force solution. Like it will take this much amount of time, which is definitely very much. Like for anyone to 15 also it will give TLE, right? But I just wrote a brute force, which will iterate over all the subsets which have the size equals to n minus 1, right? And by using DSU, I just found out that are those edges forming a tree, and if they form a tree, then is there some like is this sum equals to, like is this sum a perfect square or not? And if it is, then I just printed that set of edges, right? So I just wrote a brute force like this, and I just printed the answer for 3 to 11. Okay, so I'll just print it once more. I'll just run this program, and I just printed this answer for 1 to 11. I mean 3 to 11, right? And I observed that I got an answer for every one of them. Like you can see that here's the output. So yeah, except for 4. Wait, why didn't I get the answer for 4? I guess it must be some issue. Like for n equals to 4, the answer is this one, right? 1, 2, 1, 3, and 1, 4. So there must be some issue because of which I'm not getting an answer for 4. But yeah, for all the other numbers, I was getting an answer. Wait, I'll just let you know in the comments, or I'll get back to this. But yeah, for all the numbers, I was getting an answer. Like for 3, for up to 11, I was getting an answer for all of them. So I just tried to observe a pattern. Like I just tried to find a pattern in these edges. Okay. So the pattern that I found was in all of these answers. You can see um, like let's say this thing. You have only 1 and 2. Like I mean, at least for n7 onwards, like up to 6, just leave it. because n is small enough for that. But from 7 onwards, 7, 8, 9, 10, 11. So for all of these test cases, you get an answer which is having only ones and twos. Like if you just look at the left hand side of these edges, you'll only find 1 and 2, right? Like basically what I observed was it is always possible to make an answer using just 1 and 2, right? So like one, basically what does that mean? It means that in my tree structure, I will have the vertex 1 here, the vertex 2 here, and all of the other vertices will be either connected to 1, either to 1 or to 2, right? So there will be a bridge between those. Like there will be some x like this, and every vertex except for this x would be either here or it would be here, right? And I can always find a tree like this, okay? So I just assume that this is such a tree, like until n equals to 6. Until n equal to 6, I just applied brute force, okay? Like if you can see in my code, if n equals to 2, I print -1. If n equals to 4, I print this thing because somehow I was not able to print it using brute force. Like I don't know why. Somehow it was not able to print it using brute force. So I just printed it by hand. And for n less than 6, I just printed brute force. Okay. And otherwise, I just did, like, I just assumed that this structure is there. Like, for all n greater than or equal to 7, I assume that I can always find a tree having this structure. Okay. So I had to find out that how do you get the values? Like, how do you choose that which nodes should come here and which nodes should come here? Okay. And what should be the x here? Okay. So what I observed was one more thing, that like okay, I just, okay, let's see what we can do. So we have an x here, right? We have an x here. Now let's say that the sum of these nodes, like the sum of value of these nodes is s. Okay. Like what I'm saying is this node is x, this is 1, this is 2, and all of these nodes, their sum is equal to x. I mean s, right? So now let's try to find out the value of this tree, like the sum of all edges, right? So this edge is equal to x, this is equal to 2x, right? So you have x plus 2x, then you have all of these edges, right? So they would be, okay, let's think about that later. You have all of these edges, right? All of these edges. So they would be 2s, right? And then you have all of these edges. So they would be just 1 into whatever this sum is, whatever this sum is, and that would be just total sum n into n plus 1 by 2 minus whatever nodes we have here. So we have a 1 that is used up, x, a 2, and a total of s, right? So basically s plus, like, minus s plus x plus 1 plus 2, which is 3, right? So this is the value of this tree. Okay. I think it is pretty simple to understand that this is the value of this tree. If we choose a node x to be right here, then the value of this tree is x plus 2x plus 2s. Like this is x, this is 2x, then this is 2 into s, and these edges will comprise of 1 into total sum minus these three nodes and this node, right? So I'll simplify this. So this will become 2x, like this and x, this x will cancel out, and 2s minus s will be s plus n into n plus 1 upon 2. And then what else do we have? We have minus 3, right? This is what we have. And this should be equal to a perfect square, which is like y square, right? Okay. So let's say we try to fix the x. Like let's just try to iterate over this x, okay, and we try to find the sum. Like, let's just write s in terms of the other variables. S is equal to y squared plus 3 minus n into n plus 1 by 2 minus 2x, right? Okay, so basically I get this s, like I get this sum of nodes that I need to be equal to this value right here. Okay, and now I just thought that okay, I have used the nodes 1, 2 and x, right? I have already used up the nodes 1, 2 and x. Okay, let's say I iterate over the x. Let's say I iterate over the x from 3 to n. Okay, so I have already used up the nodes 1, 2 and x. So what are remaining? The other ones, right? So if my value s comes out to be any of those values, okay, like let's say okay, first of all, um, I have this number right here. Actually, I think I made a mistake. Just a minute. Okay, no, I did not. So let's just write this as like this: s plus something, s plus something, that is n into n plus 1 by 2 minus 3 plus 2x is equal to y square. That is, you want some s, like you have this constant right here. If you iterate over this x, then this number is some constant, right? And you want to add s, you want to add some number to make it a perfect square, any perfect square that is. Like you want to just add some number to this constant to make it a perfect square, right? And that number, like if that number comes out to be something between 1 to n or something between 3 to n, and also if it is not equal to the current x, then simply we can take that one node, right? We can simply take that one node to be s. Like if I take example, if I take, let's say n equals to 8, okay, n equals to 8, and let's say we have x equals to 3, okay. So what do we have here? The formula is that um, we have some s plus this term would be what, 8 into 9 by 2, 36. 36 minus 6, 33 plus 2x, 33 plus 6, 39. 39 s plus 39 is equal to a perfect square, which is y square, right? So what do we add to this 39 to get a y square, to get a perfect square? So essentially what we can do is we can add a 10, right? But a node cannot have a value 10 because n is equal to 8 only, right? So it is not possible if we keep the value of x as 3. But what we can simply do is we can increase the value of this x, okay. So it will essentially make this value, the 39, it will make it increase, right? So let's say if we make the value of x as 5 instead of 3, right? So if we make it 5, then this value will become, wait, not 5, let's make it 7, okay. So if we make it 7, then this value will become what? Let's, so it is 36, sorry, 36 minus 33 plus 7, which is 40, what is it? 47, right? So that doesn't work either. Let's say x equals to 4. Yeah, I think 4 works. So initially we took 3, right? Initially we took 3 and the value was 39. So if we take 4, then this 2x value, it would increase by 2. So it would become 41, right? So we want some number plus 41. should be a perfect square. So let's say it is 49, like the nearest perfect square is 49, right? So we would want s to be equal to 8, right? And since we have n equals to 8, we can have this 8 as a single node value, right? So we'll just put this single node 8 as the neighbor of 2. Okay, we'll just put this 8 as the neighbor of 2, and x equal to 4. That means the intermediate node is 4, right? And the remaining nodes I'll put with 1. That's the construction. That 1, 4, 2, and 8 here with 2. And the other nodes, that is 3, 5, and 7, and also 6. 1, 2, 3, 5, 6, 7, 8. Yeah, so I'll put it with 1. So now you can see that the sum should be a perfect square if I'm not a stupid person. Okay, so let's calculate this. 6 plus 3 plus 5 plus 7 plus 4 plus 8 plus 16. Okay, so 14, 21, 25, 33 plus 16, 49. Yes, let's go. So that's what I'm constructing. Like what I'm just doing is I'm iterating over the values of x. Like as you saw here, I first tried the value of 3. I tried the value of 3, but that was too small. Like that made the s too big. So now I increased it. So I tried 4 now. And as you can see that s came out to be a number which can be a node. Like which is between 3 to n, and which is not equal to x, right? So we can just keep iterating from x equals to like 3 to n, and we will definitely get some value for which this is satisfied. I mean, this is just a guess. Like it is just trial and error, right? Like I just observed using the output that for every n greater than 6, I can make a tree like this, and it will always exist. That was one of my guesses. And one more of my guesses was that I can always find out, like if I just iterate over the x, I can always find out a tree such that the remaining node is a single value, right? If it is too large, like if the gap is too large, then we just increase the x. That was another of my guesses. So I just wrote this code, and I ran it for all n equals to 1 to 1000. Okay, and it ran on all of them. So I just concluded that it is correct. I don't have a proof of why it is correct, but I just tried it. Okay. So what I did was, in my code, if n is 2, then print minus 1. If n is 4, then just print this hard coded. If n is less than equal to 6, then just brute force it, right? And if otherwise, I'll just iterate over x equals to 3 to n. Okay. So x is the middle node, right? So now val, like I have this array which is having all perfect squares. Okay. And val will be equal to, like what I did was this value right here, right? Um, s plus something, we want perfect square. So I just found out something ka lower bound. Okay. So like for certain x, I found out the perfect square which is next to that value. So which is val, and del equals to val minus that value. So if del equals to x, that means if it is already used, or if del is greater than n, or if del is less than equal to 2, then I continue. That is, I can't use this del and x plus plus. Otherwise, I will just print this del with 2. Like I just print 1x, 2x, and 2 del, and all the other vertices with 1. So if I is equal to x or del, then continue. Otherwise, just print it with 1. Okay. And also, I am just like summing up also, so that at the end I can assert. Like I just did it so that I can check my code. All right. So that's my construction. I mean, it's pretty guessworky. Like I can't prove it why it is correct, but I just ran it for all the numbers from 1 to 1000, and it worked. So if it works, right? So I just did that. So is it clear, guys? Yeah, it was difficult. Like even after, like when I was testing, then also I took 1 hour and some minutes. But yeah, okay, it is clear. All right. So any doubts, guys? Just let me know. I just showed the code also. Just let me know, everyone. No doubts. Okay. Then I guess I'll end this stream as soon as I can because it is already too late. So I will just go and yeah. All right. Thanks everyone for joining in. Thanks everyone, and I'll see you guys next time. Happy Diwali, everyone. I mean, I'll probably see you guys on Sunday as well because I have a PCD at that point as well. So I'll wish you guys on that day. But for now, Happy Diwali for now. If someone doesn't join in on that day, I guess most would not join in because they would be busy in Diwali. But yeah, all right. Bye everyone. Good night. Shabak here. Okay. Bye bye.